Friday, so it's Friday. It's Token Drop podcast time, DaaX Token Drop podcast time. And what I think we should talk about this week is domain superintelligence, and within that, knowledge graphs and ontologies. And ontology still, to me, Sajat, even after working with you on them for so long, I didn't even know what a knowledge graph was. I didn't even know what an ontology was until you mentioned when we worked back at Wipro many years ago. And I think I kind of got it, but I'm still a little fuzzy. And so maybe we can start by just me telling you what I understand an ontology is, and we can take it from there.
Sure.
So to me, what an ontology is kind of a combination of an org chart plus a dictionary plus a thesaurus. So if I look in a company, you have an org chart in terms of different departments, marketing, sales, HR, engineering, et cetera. And how they work together is kind of an org chart. Then and within that department, marketing, you have different roles, and that's in your org chart. And there's a description of how these roles work with each other, what they do, and they work with each other. Then you have a dictionary of terms that have a definition, like let's say the word in sales spiff, which is a sales incentive that you might give to the field sales team. There's a word spiff, and there's a definition like a dictionary. And then there's a thesaurus, which is synonyms for the word spiff that's used within that company. So that's kind of my business view of what an ontology is. So am I on the right path? Completely wrong? Hopefully
I
I'm not
think you're
wrong.
on. No, not right. I mean, you're on the right path. It's a schema for modeling knowledge. So in a given domain. So it's not general purpose that applies to everything in the universe. That's much harder. So the whole idea of ontologies is to model domain knowledge in a well-defined domain in a way that you can then use uh, the schema, the business vocabulary and taxonomy there to transact business. So we all have then end up having a same shared understanding of what each of those terms mean, how they are related, what are their properties, and so on. So that's a good organizing framework for knowledge. And when you also use the word domain superintelligence, and that's really what we're hearing all too often. Unlike a general purpose LLM, domain superintelligence here means that in a narrow enough domain, you have enough knowledge and enough expertise that you can call yourself the best in that given domain, so in that narrow sliver. So, and that seems achievable, pragmatic, and practical, and more so for business functions, right? If you're trying to automate certain business functions, those business functions are well defined. They're quite narrow that you can actually scope them out reasonably well. And you can choose to apply these concepts to automate those domains. Um, and that's really where these ontologies come in handy when you combine them with general purpose LLMs and some specialized domain knowledge, domain rules, and business taxonomy. It gives you enough, and that's quite a bit of tools that you have now in your inventory to attempt to automate that domain.
It seems like these are becoming more important in the industries in different domains because now you have industry associations that are creating these ontologies. Like, and we talk about oil and gas being OSQ, finance is FIBO, and it seems like there's a move amongst industry participants to create this common ontology. And just wanted to see what you thought of it. Is it kind of an old trend that is not really continuing today, or is it going strong?
It is. I think it emerged from um, I think, just post the dot-com era. The World Wide Web had just been invented, and people were beginning to appreciate the value of the World Wide Web. And then I think the Tim Berners-Lee and a bunch of people, they thought that organizing that worldwide knowledge would be achievable if you had ontologies and taxonomies to organize that knowledge. So they started creating standards in the W3C. And those standards have been evolving. I think uh, initiatives like the Wikipedia initiative, they use those standards. And then certain industry domains like healthcare, medicine have been using these rigorous uh, definitions of terms and meanings associated with those terms, because the rigor of that meaning attached to a particular term is particularly relevant and critical in the medical domain. When, as a doctor, I tell you that I'm going to administer a painkiller for you, I need to be precise in what I'm saying. And you need to understand what I'm saying. And what I'm saying needs to be understood by anybody in that medical profession. And it should mean the same. So I think the need for standards for semantics is your understanding of that concept, was critical. So the medical domain embraced it, and then slowly the financial domain also embraced it, because once again, precision and accuracy associated with concepts and understanding and semantics and meaning were quite relevant there. So those domains adopted. But in our context today, I think what we are beginning to realize is that that's a good organizing principle with which you can manifest knowledge and the rules associated with that knowledge in that domain, and to use that to build some kind of guardrails around LLMs. So LLMs are as useful as they are, and as deep and as wide as their knowledge is. Sometimes the generative aspect of an LLM could go uncontrolled. So you want to be able to control and constrain that. So this tool is a great tool to actually manage that.
I remember when we were talking about this a few years ago with a customer, and we were talking about creating ontologies. They were saying it's going to take them, 6 months, 9 months, in a team, a pretty good sized team of engineers
Yeah.
who got together and created an ontology. So it seems like these industry groups that are taking this on are providing a good value to their participants.
Oh, absolutely. Just take a look at the Wikipedia effort. It's a humongous global.
I'm not, oh, you mean Wikipedia has an ontology?
It is. I mean, they're organizing knowledge by some ontologies. They're using Sparkle RDF standards. They're trying to be as standards compliant as possible. And of course, you're starting to see these emerging industry organizations like OSDU in the oil and gas industry, FIBO in the banking industry, healthcare, life sciences, insurance, every industry where there's fairly rigid compliance and regulatory oversight. You think those are the industries that would tend to adopt ontologies much more rapidly, because it's there in their own benefit. Associating meaning with a given term and making sure that that definition is unambiguous, is well understood, and all aspects of that are well known, all properties are well known, and how it's linked to all the other terms, it's well known. So I think these standards provide immense benefit, and it's a service to the community of users at large, that you can actually use and build your own solutions around.
So these ontologies, are they specific to a type of knowledge graph, or are they just generic and you're supposed to apply them to your knowledge graph
That's an
implementation?
interesting concept, right? See,
Because you mentioned Sparkle or whatever. So
first
there's
of all, yes, yeah. First of all, there's the ontology, which is how do you organize your knowledge?
yeah.
Now, that is regardless of your implementation choice. It's like the database schema.
Right.
You got a database schema. You can use that schema in MySQL, or you could use that in Oracle. You could use that schema in any database. So quite like that, the ontology is an abstraction that's sort of technology agnostic. And you can render that in in a defined platform. It's a function of the database that you end up picking for graph storage. So in the past, almost every graph database would strive to comply with W3C standards like RDF, Sparkle, and uh, and such. But now we're starting to see the emergence of graphs that are just called labeled property graphs. Uh, they're not that rigid on the use of RDF, OWL, and Sparkle standards, but you can still render an ontology. You can still organize knowledge. It's a little bit free form, not as constrained, which means it's easier to program with and rapidly build solutions. So it's a hybrid between very rigid, stringent, standards-oriented designs as compared to something midway between them and an entirely free flow architecture. So yeah, and then so it's a function of those graphs. And I think if you look at the graph database industry, um, I think an emerging query processing standard is called GQL. GQL is almost 70-80% cipher. Um, and that is quite slightly different from Sparkle, which is much more rigorously standards oriented. So you can see across the industry, there's a little bit of a loosening of these standards to make it easier to program the systems, rapidly build and operate the systems. So we're seeing a drift in that direction. And it's probably a good drift. You still get the benefits of organizing knowledge, your ability to organize knowledge, and still benefit from the emerging scalable new age graph data stores. So that's
One question, and I had for maybe for Sam is, we're here in Silicon Valley, and Silicon Valley obviously got its start from silicon and then moved into systems, and now is a bunch of other things. And the ontologies that I'm familiar with are more from domains outside of silicon and networking and things like that. And I've been involved in standards committees on, silicon, for example, or networking. I'm just wondering, is there going to be a move afoot to create these ontologies for semiconductor or EDA or networking, or, do you see anything like that, Sam? Or is there anything
I
like that
think there
already?
is. Okay. I mean, to answer your question, Sonal, I do see that there is a real a move towards that, especially in the semiconductor industry, right? I mean, to give you a brief history, right? Domain modeling has been there forever. Sajad knows that I've been involved in earlier in standards in the storage, like the Bluefin specification, the SIM specification. We have been involved in that. Now, the real problem today, everybody thinks is knowledge graphs and these ontologies are really very difficult to maintain, right? I mean, that is one of the things that people really say. It
Why are they
drifts.
difficult to maintain? I mean, language in an industry doesn't change dramatically year to year to year. Maybe a few new terms might come in, but why is it so difficult? I don't understand that.
So the real that's where the real problem happened was when originally people were trying to do these ontologies, what they did was they were handcrafting it first, right? And second thing is they were doing a giant top-down, boil the ocean kind of ontology by a committee, right? I mean, before any value was delivered. Now, the problem with that is people keep on defining this forever. And by the time it is realized, it's almost about 10 years.
Yeah.
A decade would have passed. And this was one of the bottlenecks that you see with systems that were being modeled to the nth degree for everything, right? Here is where the subtle difference lies. When you take a concept like domain-driven design, like when you take that, you only take the portion of the model which you are interested in. You drill down into its details, but rest of all the things you do not worry that much, right? It is a portion of the model that you're interested in, so that really brings down the surface area of the ontology itself, actually. So when you define something, it becomes very specific. And that is doable, actually, instead of boiling the ocean kind of approach. The second approach I really think, which is broad, which has made things easy, is the LLMs, actually. So the main hardest part was to really process this information, convert it, and deal with the documents and etc. Right? That the LLMs take care of it right now. So two aspects of the original problem domain are pretty much minimized, because in the sense that LLMs do the heavy lifting, the human extraction, reading the documents, identifying entities, relationship, normalizing the terminology. That's what language models do.
Yeah.
Actually,
Isn't
right?
an ontology just a representation of language? And language is what large
Exactly.
language models do. So why
Yeah.
can't you
Exactly.
use an LLM to do this?
Correct,
So
exactly. So you
yeah,
craft an ontology once,
yeah,
and then you extract knowledge from these documents
yeah,
using an LLM.
yeah,
And then you could also have a human in the loop if it is that critical.
yeah.
But once you have the knowledge organized in the graph, you can apply that for any number of use cases, right? So it
Exactly.
becomes usable. So I think the investment in time and effort um, can be justified by the return on that investment. And then the LLMs are helping you accelerate that. So yes, in the past it used to be laborious. You needed specialists, domain specialists, ontology specialists, special tools like Protege. I remember Stanford had open source a tool called Protege. It's almost 15, 20 years old. So we used to use those tools, and we used to hire ontology specialists and domain specialists, and you had to bring everybody into a room, sit down, get them to agree. Even if they reach some kind of an agreement, some other department, some other division may not agree entirely with you. Then you have to bring them into the loop. Yeah, it was hard, but I think LLMs can help accelerate some of that. The fact that you need to still reach consensus with other people, you can't short circuit that. But what you can certainly short circuit is the automation for
Yeah.
extraction and
Well, that's
augmentation.
where these standards committees have already kind of done that. They know how to get these agreements across multiple companies.
Yeah, but even so, I think these ontologies may need to be adapted to a given organization.
Correct.
Because
Exactly.
each organization might have an interpretation of those terms and manifestation of the terms with their own. How do those terms manifest in comparison when you start looking at their products and services that they have to sell? So how do you fit the products and services within that taxonomy? Yeah, so there's a little bit of adaptation work, but by and large, yes, the open source ontologies that are out there, contributed by industry bodies, organizations, associations, yeah, I think certainly helpful.
I've seen more papers on this too, more academic research on ontologies.
Yes,
No,
correct, exactly. There's a lot of, I think it's a growing trend now. If you look at Google Trends, you'll see this is actually a trending topic. Whereas just 2 years ago, people wouldn't pay attention to this domain. And in fact, I think I remember the 2 years ago in the Knowledge Graph conference, there's a conference called Knowledge Graph Conference that happens in New York City every year. There was people are starting to justify why graphs are necessary and important, because they were beginning to feel the pressure that graphs will go away. With the emergence of LLMs and people using LLMs, there may not be a need for these kinds of graphs. So, but that has gone away. I think this more recent KGC that I saw, I think there's significantly far more enthusiasm people are doubling down on this. So yeah, I think we are starting to see people beginning to realize why this capability is an important capability to supplement what the LLM can do.
Sam, you look like you wanted to say something.
So what I was trying to say was when Sajjad touched upon it, right? Scope. When the scope of the ontology, which is the single biggest lever on the cost, is scoped, right, and is entirely under your control, things become a little bit better. The second thing Sujat touched upon was the automation ingestion pipeline uh, that can propose the graph, the extract what entities to extract, the relationships, the candidate terms. And it's still the humans are involved, like what Sujat said. There is a review and correct role rather than author from scratch role. The author from scratch role is gone. This is only a review and correct role which we have right now, right? So that reduces this. Now these are two important things. The third thing is the question is with AI. The main question that we have to ask is why are these so important, right? And why this is important, because these ontologies give the explicit model of meaning, right? I mean, so a shared explicit model of meaning is given by these ontologies, right, to AI, and they make reasoning possible, right? And why is this very critical? They constrain generation and curb hallucination, as Sujat put it earlier. And the one thing is it enables interoperability across the silos and standards. So there are many, many benefits of these ontologies, and they also make AI explainable and auditable. Now the question is, okay, if it's not for ontologies, what would happen? What is our alternative? Now that means you're leaving it to the LLMs. And you know what that means actually, right? When you leave it to the LLMs, now the question is, you still have to really, it's an LLM that you reprompt, refine tune, and reevaluate every time your domain shifts. Where is the traceability into what it actually believes? And how do you surgically correct a single wrong fact? This is all not under our control. But in a domain graph, what do? With a graph and a fact changes, you just update a node actually. And boom, things can change. And the change propagates through the inference. With a pure LLM based approach, when a fact is changed, it is impossible for you have no idea where it lives and whether your retraining fixed it or not. You're left to pray, actually, right? I mean, or if it broke three other things, how do you know that, actually? So that is the real problem there. What is the alternative if it's not for a knowledge graph? You're leaving it to the LLM. Would you want to do that, actually?
Mm-hmm.
That's the question. And we do not know where it lives and where it is maintained. And if you retrain to fix a particular problem, how do you know it did not introduce other things in there? And how do you know that things did not, other relationships did not break? You have no idea, right?
And
So,
it's also a bridge between an LLM by and large has been trained on internet data, and it may or may not understand the business terminology and associations and concepts that given business users. And that data is dark data, right? It belongs to the company. So the company people, if they were able to define an ontology for that business process or for the set of products, and then combine that with LLM, I think that ends up becoming the last mile bridging segment, right? The graphs end up bridging what the company wants and what the LLMs are capable of. And that's one short pathway to domain superintelligence.
And that's an interesting term because I just recently learned that domain intelligence, superintelligence, is actually a technical term. I
It
thought it
is.
was a marketing term because I go up on
Yeah.
the billboards on Highway 101,
Yeah.
and you see them all over the place. And I thought, man, they're pushing it. I have a lot of
Indeed,
exaggeration, but actually
because
it's a technical term.
it is because you are now constraining your field of operations to a really, really narrow domain. right? Accounts receivable or accounts payable, or you think of CRM, customer relationship management. When you define a domain to be as narrow as that, then you can afford to go pretty deep in that domain, right? You can build ontologies, go pretty deep, customize them, adapt them to your business use, right? Each business has its own terminology. So I adopted for that business terminology, then constrain the LLM and its generative processes and the verification processes to within that narrowly constrained domain afforded by this ontology and the graph serving as guardrails. And that's a viable pathway to domain superintelligence.
And domain superintelligence is the next level down from AGI. Is that the way to look at it?
Yes, AGI is spoken of as more generally as general superintelligence, which is what everybody is shooting for, right? It's like shooting for the stars.
Mm-hmm.
And nobody knows when we are going to achieve AGI. For sure, the current breed of LLMs and the current architecture is falling short. It's not going to deliver on the promise of AGI. You need something more. And we don't know what the post-transformer architectures are. So there's a lot of unknown. But for those who are in a business, who are in a hurry, who need to automate some processes, who need to use AI to benefit from AI, I think the pathway that we just described is a pragmatic pathway to at least automating something and benefiting from the available technologies that are out there.
The
Okay,
other interesting aspect
Sorry,
is
Sam, go
Sajad talked about domain cartridges in a earlier session. Actually, you guys we talked about it also, and that why I want to bring it is brings the economics, right? I mean, of reuse. So, in other words, once you built it, the cost it gets amortized. That's the point I wanted to make. I mean, Sajad, you could talk a little
Yes,
bit.
absolutely, exactly. Because once you define these ontologies, whether it's account receivable, accounts payable, or a given business process, companies tend to stick to those processes, run those processes millions of times. So yeah, you define that process once, you define that ontology once, and then run this process through it zillions of times. And so you're really speaking to how do you amortize those costs. That's what Sam's referring to. And then you're getting reasonably, better than LLM accuracy, but when you constrain the domain and you have all of these guardrails and verification around that. So yeah, and that's really where, and businesses want that level of accuracy, right? And nobody wants anything less than 100% accurate.
Right.
But in classical data science, you're only talking in terms of percentages. We're talking all of those leaderboards talk about 70% accurate, 80% accurate, 90% accurate. Nobody's talking about 100% accuracy, right? So,
Okay, I think we've run out of time. So thank you guys. Have a good weekend, and we'll talk to you all soon.
Thank you.
thanks.
That
Thank
was
you.
a great discussion. Thank you, guys.
Thank you,
you.
guys. Bye-bye.
Yeah.